from all of you. So your goal throughout the semester would be learn as many related things as you can and help me learn too. So there are lots of activities to be done. One is going through some research papers and finding out what people have been doing. Is there anyone who is good in programming in any language? Can follow given examples? Can modify given program? Understand code written by others and modify it. I'm not expecting you to write codes from scratch, but tinkering. You don't have to say, you see a code, you don't understand it well, you change things, tinker and see what changes, right? So experiment with that. All right, I'm going to disconnect for 1-2 minutes and come back. How is the audio?
Good, sir.
Okay, excellent. Okay, so okay, I'm repeating that if anybody if there is any issue with audio, please do let us know. I hope the screen is visible. Okay, first I would like to show where we are. This is October month, right? Month of October. We are here on October 12th. When is the midterm?
17 November.
Midterm starts with the from. Midterms start from October 15th, November 15th. So our midterm is likely to be on 17th. Okay? How far is that? এখন থেকে কতদিন পরে? This is 12, this 1 week. So if you count from there, 1 week, 2 week, 3, 4 weeks. Unbelievable. Right? What's our mental model? 2 months of class, midterm exam, another 2 months, right? That's what we believe. Realities, so have you seen any writing on car rear view mirrors or looking glass? Objects appear closer than they appear. So it seems midterm is 2 months away, it is 4 weeks away. And 4 weeks is not 1 month. That's 4.5 weeks or so. So midterm is very close. Okay. Do you like more syllabus or less syllabus? Depends on purpose. For exams, you want less syllabus. For learning, you want more syllabus. Okay. The first is you are just starting the courses. Things are very basic. You're learning, and from you are learning. So to keep things basic and easier for you, in today's class, we are going to discuss different types of parallelism. We'll try to motivate why this is needed and different types, maybe some small formulas and mathematics. Okay, so I want your opinion. Would you like to sit for a quiz based on today's class or next Sunday? Or would you like to give the quiz on next Sunday based on 2 classes of syllabus? And each class means actually 2 classes, right?
Next Sunday.
So would you prefer, let's get the dates done. Next is a relative term. So would you prefer quiz on 19th or would you prefer quiz on 26th? Regardless of the date, the syllabus will be everything taught up to that point. So is next Sunday okay versus, so do you do like 19th or 26th? Which one would you prefer?
Sir, 19th would be better.
Sir, can you make it 26th? Like I have a quiz on the same day.
You can prepare beforehand.
Can the master's student do 19th?
Okay, so okay, I would like us. Okay, if we have turned off the speakers, so those who are speaking out, please write on in the chat. Okay, it's a good thing that we can see the history of captions. So Sarah Milham says 19th. Rajesh says 6th. Oh, that's a different thing. Okay. Nababi says 19th. Okay. So let's have a vote in chat. 19th versus what? 26th. Thank you for that. That was Atif, right?
Yes.
Thank you. You get called out. We have 26 people. So again, what are we discussing? We are discussing small syllabus versus the double syllabus. If it's on 26, it's going to be double the syllabus. If it's 19, it's just the introductory lecture, today's lecture, which is definitely don't have a lot of material. Okay, so you are not just deciding that, you're also deciding the syllabus. Syllabus is not constant, it's relative. So if you do it on 26, it's going to be the double syllabus, means syllabus of today and 26. 19 combined will be syllabus. Okay, so those who are present, you have to convince the absent people as well. Did we have a change of votes? So let's hear from the 26 people. Jannatul, Mirza, Shadman, Abu Bakr. We had 26 votes. So would you like to re-vote? Is it changing or is it the same? If your exam is on 19, the syllabus is only today. If it's on 26, syllabus will be both today and 19 topic will be there. Your choice. I have no say. Your choice. And it's gonna be a very short quiz. Even whatever we discuss today, it may not be asked all questions in next quiz. Maybe some topics will have to go forward to quiz 2 anyway. So maybe today's lecture or less than that for first quiz.
So question, how many quizzes will we have before the midterm?
At least 2. At least 2. So we'll try 2 before and 2 after, or 3 before and 1 after. So whatever is feasible. Because afterwards it's going to be even tougher. That's winter. you'll probably run home earlier. Okay, so we are getting majority votes 19th and few people on 26th. Quiz is 10%, I believe. And also it's 10 marks as well. Okay. Any other questions? Anything? Okay, what we have for the course. Okay, I have a question for all of you. So based on this discussion, do you think is 19 finalized? As most of the people said. But those who have I am teaching a second course, which is on the same day having another quiz. Okay, that is why some students are having a doubt. So what we can do is we can try making the quiz so more introductory, because it is introductory anyways. So this is a dream. This is a dream about the course. What is the motivation? The motivation is looking at design, analysis, and implementation of some parallel algorithms. So parallelizing computation in some way. Why? We want to get more things done. It's the same reason why you do group projects. You want to get more things done. All software team company. So there are very few one-man company, right? So most of the people work in the groups to work in parallel. So do all of you know how many cores you have in the CPU course you have? Does anyone know? No.
Course.
Do you have a phone? Smartphone? Everybody has a smartphone? Sure. Let's test if the user is smart as well. How many cores do you have in your phone?
4.6.
I don't know, you have to tell. I have not used your phone. Can you prove it? People are saying 4 core, 8 core. Can you prove it? How many cores you have? Do you have a smartphone? Do you have a smartphone?
Yes, sir.
How many cores in there?
4.
Sure. Can you prove it?
Yes, sir.
Sure.
I mean, how many courses I have taken?
Not courses. How many core of your processor of the phone?
Oh, no, sir. That I can.
Okay, see if you can figure out. Okay. Now comes the burning question. Quiz is online or offline? This is, you see the status, right? We cannot fit in all them here. So, but in-person people, so 449 people will be giving it offline, in-person here, and they will be giving online. Okay? But your quizzes will be in person. Is that okay? So 7 to 6 is online, and your people is offline. Anything else? Okay. So first task you get is find out, and this is completely optional task. Find out. Not cores. Core, CPU core. How many processing core you have in your phone, and you see, additionally, it would become part of the quiz question. Then what will you do? Okay. So, resources. Computing resources. What are your computing resources? RAM. RAM. Anything RAM? Anything else? Do you have anything other than RAM?
Storage.
Storage. RAM is also kind of storage, but what do you mean by storage?
Volatile and non.
Volatile and non-volatile.
Register.
Register. Okay. I have a quick question. Yes. Have you heard about RAM and ROM? What is ROM? Read-only memory. Everybody knows that. Excellent. Read-only memory. What is RAM? Random access memory. Is that okay? Good. Now tell, is ROM random access or is it sequential access? ROM.
Isn't RAM sequential and ROM is not sequential? I don't know.
We are very glad that we are having this discussion here instead of any interview board. Okay, RAM is random access. What does random access mean? It can access any position directly. Think of it like an exam hall, admission test hall with enough gaps in all directions. You can directly go to any seat. Versus sequential access is like a tape where you have to sequentially go. It's like a say book without page numbers. You're trying to find out something, and you cannot turn pages from the middle. You have to turn one by one. It doesn't allow you to pick a middle page. Or like a cassette player, you have to go sequentially. So if you have to access chapter 5, go through chapter 1, 2, 3, 4 first. That's sequential access. So tape drive is sequential access. Do you understand tape? Audio cassette, video cassette. Have you seen or heard about those things? Okay. So those are sequential access. And tape drives are still used by museums and archives because they have long-term retention. Do you have a hard disk or SSD? What is the expiry date? Do they live forever? Did you keep data in your SSD and think it will live forever? Or even hard disk? They don't last forever.
It has a many times you can read and write from it.
Right. Even if you leave it there, it's not going to live forever. It will get oxidized. Unless unless you're keeping it in a vacuum room. I don't think any of you have vacuum rooms at home. They'll live forever. So what do governments do, libraries do, museums do? How do they keep their data? They have to keep transferring this data to new mediums every 50 years or 10, 20 years. Like they'll keep changing because the device will wear out. We were thinking about making a mini supercomputer here out of all the old machine that we are decommissioning. We stopped. Why? Because that's a fire hazard, because all the wire security is integrated. Does it make sense? Because oxidization will create short circuit, that's a risk. In short term, you can. In long term, that's a problem. You have to actively monitor which one gets oxidized or getting wear and tear. Okay, so coming back, sequential and random access. ROM is also random access. So ROM, digital, it's electronics, you can address any bit in time. Both are random access. One happens to be read only, and another is read and write. I have another question for all of you. Do you think ROM is read only? If ROM is read only, what do you read if you don't write it? Does it make sense? If ROM is read only, what are you going to read if you have never written anything to it? Maybe it's write once and read many times, right? That is possible. Usually, ROMs are firmware stored in ROM. So your BIOS is stored in a ROM. Your in hard disk controller and other stuff, DVD writer, so they have ROM. Your Wi-Fi router also has a ROM. What is there is limited time writability. Maybe 3 times, 5 times, 10 times. After that, it will fully turn into ROM. That means you cannot write anymore. So if you upgrade too many times, it's going to stop the ability. It doesn't have lots of rewriting ability, limited times. So I had a CD writer. Then I upgraded its firmware several times, and then it became a ROM. I couldn't write it anymore. It says successful, but it doesn't work anymore. So, okay, so resources like what? Memory, CPU, and GPU, or TPU, any processing unit. What else do we have? Storage, other storage. So so permanent data stored. So non-live, so non-volatile. Okay, what else do we have? Maybe a network. Network have something. So different types of things are attached to a machine. So going back, we have different resources, CPU, GPU. So we'll think about how we can think in parallel. We'll look at a small amount of theory. We'll look at some practical implementation. Okay. So broadly, we have 3 segments: some theory and some concepts, some formula, some definitions, some concepts, some ideas. Okay. So that's the first goal. Second is being able to comment on some parallel architecture and some form of work in parallel. Third is looking at the programming techniques and related research people are doing. So 3 domains. So if you know programming, you can go in one direction, you can do implementation heavy. If you don't know programming or dislike programming, you could go to the theoretical side. You maybe survey what's available there. So different people with different, we have a mixed audience here. So different people will have different background. You can choose maybe a research domain, you can choose more of a practical domain, so your choice. So we tend to try for individual assignments instead of group. We'll think if we do something later. So you look at the latest programming tools are there and to study about research. So you will be required to have some assignments where you'll read papers and comment on those research work, what they have done, how they've done it, and again, as if you're the expert, we'll comment on that. Just as an exercise. Definitely, it will take some time before we gain the ability to comment on their research because they are our pioneers. But still, we'll try so that we can learn by discussing those things, their work, by other researchers. Okay. So the dream is some of the computation. These are the topics. So this is an evolving course, so this is the tentative plan. Today we'll be talking about different types of parallel computing. Next days we'll look at some of the concepts related to parallel algorithm design. Gradually we'll see, do you remember sorting and searching? Bubble sort, merge sort, different types of sortings. We'll see if some of them can be parallelized. There are other types of algorithm like graph. Then we see if GPU programming can be done, or at least we can see depending on resources. Now, some of these topics will require specialized knowledge, C, C++, maybe Python, but people have done parallel programming in many different languages. So many of you might think Python is slow, right? There is a common belief Python is slow interpreted language. Do you share the idea? Python is slower than C, C++. Definitely is slow. Then I have another question. This is a government website, right? I did not, disclaimer, I did not read these websites, okay? And I'm not trying to sell Python. This is some US government office, and they say supercomputing with Python. And that was year 21. And there is another government agency which says accelerating and scaling Python for high performance computing. That's close to supercomputing. And Argonne is, that's probably a national lab, and they are using, and you guess what's written afterwards, right? High performance computing. NASA is using Python courses. They also need to work with lots of data, right? Astronomical data is huge data. What? The ocean people? They're also thinking about Python. So lots of US research lab, which many of them have their own supercomputer anyway, by the way, and they're using Python. Of course, they're not completely using Python, only using Python. They also use C, C++, another language. Guess which one it is?
For analytical data processing.
For parallel so simulation, security, other stuff. It's a very old programming language.
Java.
They're using also Java. They're using Java, but also old programming languages. Fortran, still being used. Fortran. So supercomputers, some people use C, C++, Fortran, and of course Python, small amount, but still Python has the entry there. So you don't just say it's only C, C++, right? So there are some scope for parallelism in many different languages. You choose your language. If you have C, C++ background, you go into C++. If you have a Java background, you choose your language. So whatever, if you want to go programming heavy for your tasks, then you choose a language that you are comfortable with. If you're not comfortable in any programming language and you want to focus on the other aspects, you are welcome to do so. Okay? So everybody can choose their unique path in their course. But we'll have some common discussions. You try to adapt that to your tasks. Okay? Does it make sense? Next, GPU-centric parallelism. Then some tasks become really, really efficient if we choose the data structure widely, intelligently. So you sort your study table in a certain way, right? So that you find things easier and better and helpful for your studies. So every people have their own organization. If you arrange data in a certain way, algorithm complexities change. Some algorithms will work faster. If you choose the right data structure, everything doesn't have to be regular arrays or linked list. So if it's a smarter data structure, it can make things really fast. So there are some parallel data structures. So midterm was written here, it will go a bit up because based on what we saw here. it will go up, because how many weeks away? We are 4 weeks away. Okay. Then if we want to collaborate, we need a team leader or some sort of protocol talking to each other. We'll do this, that. So some sort of coordination is required. So synchronization, concurrency, control, we'll talk more about that, but we'll start talking about this earlier as well. We'll start from here, we'll start talking about here. Because we need some sort of synchronization. Here, it will be helpful if you have done some sort of course related to operating systems. So we'll need some bit of operating system, some bit of computer architecture, and some bit of other courses. If you have done Unix, that's also fine. Load balancing and scheduling or scheduling, you have to distribute the work either to multiple cores, multiple computers, multiple devices. So we have to think about that. Now things have to be fault tolerant. Have you ever done a group project? Did everybody work equal amount? Did everybody show up all the time in right time? People vanish, right? The day before project submission. It can happen. People can get sick anytime or have difficulties or maybe scared, but maybe they cannot tell or cannot face the tension at that time. So fault tolerance will be there. Fault will be there, and we have to design things in a way that we're resilient to failure. How many of you can guarantee that you'll be in very good health on the day before midterm exam? Anybody can guarantee? You'll be in perfect health. You'll have your superpower on that day. If you cannot guarantee that, then how can we leave all of our studies for that day or that night? That's hope, right? ছটায় ফেলবা পরে নিচে ফেলে যায়। Not written time. You'll probably have some equivalent tasks. Okay. Now this is the lucrative part. What we do, we run lots of models, right? And we run each of the model, we're running out of resources, then compare. What if we could run models in parallel and then decide? And this is a living topic. This course has been evolving for, I think, what, more than many decades. People have been thinking about this even since before 1965. So it has been evolving. It's evolving. If you get time, we'll think what new things are coming in, or recently. Recent means last decade, because things will keep evolving. And then we'll have some presentations. But as you see, this semester would be interesting. We don't know there will be 14 weeks or not, so we might have to squeeze and pick and choose some of the topics. So the syllabus might need to be reduced to be able to meet the semester timeline. So if you miss something, please do study that during semester break as a self-study. Okay. Now, do all quiz go well? Not always. All assignments go well? Not always. And sometimes at the end of the semester, we are running for 0.5, right? If we had 0.5, we would have reached the next step. So department also has some policies for that. So now, to help us giving you 0.5 or even 0.01, you need to help us as well. So we encourage some prior learning as well as any new thing somehow related to the course. Some self-study that I have done, followed that tutorial, completed some book, implemented something, written some code, or tried some simulation tool, any extra activities, 1 activity, 20 activity, whatever you have done. So we'll try to recognize that by giving at least 0.01. So that's extra credit. We encourage you to start today. Anything related to course. Don't wait for the course to go, because we'll be discovering the syllabus, we'll be thinking about the course content as we evolve, right? So this is, for the whole thing is tentative. We'll keep replanning, adjusting our plan based on our progress and available resources. So we're looking for some sponsors. If we get that, we might get some resources, inshallah. So these are some helpful books. Those who want to go into programming side will also find you some other books or texts for theoretical parts. This is the tentative plan. The quizzes are 10%. You'll be proposing something, maybe doing some practical stuff. Midterm is 20, and related some task and some final code. So coding is a bit less, it may change to 10% or so, like that. So what we have tried is redistribute everything into small amounts. So that if something go wrong, a lot of things don't go wrong, right? So no major grade assignment in any component, which is helpful for protecting your grade, but it also has a risk. That means you have to be regular in all the tasks. Don't wait for the last one. Deadline is for the people who want to reach the line of the dead. So stay away from deadlines. Again, we try to be flexible, but try to submit earlier. Of course, this is not something, for all other courses, you'll get similar courses, right? And this is a type of unique topic. So we understand that. So we'll try to offer you flexibility because some topics may require you to learn for maybe 3 days. Some topic you can understand in 3 minutes. So we'll try to offer you some flexibility so that you have some time to understand. So all the deadlines are tentative and flexible. So by default, you didn't even have to ask. By default, they have 1 week extension. If I say submit something within 7 days, that means you are automatically getting 14 days. Does it make sense? But try not to take much more than that. Our deadlines are suggested dates that they recommended. If you submit by those dates, it is better for you for load planning. Otherwise, later it will be more pressure on you. So to keep things easier, try to do things earlier. Okay. Is there anyone who is good in programming? Anybody like programming? Okay. Excellent.
Sir, about the concept,
Right.
the assignment.
Right. So it's
So is it the proof of concept for our
no, not that. Proof of concept is the implementation.
project implementation?
Right. That's the proof of concept. Yes. Concept paper is you review a paper and understand that. So you develop your concepts. Of course, the name is a bit misleading.
Sir, is the project related with?
No, you are building ideas for project by looking at other people's work.
You can elaborate on the hands-on exploration.
Given some tutorial, you try to replicate that. Follow tutorial, follow some practical work, and redo that in your machine or a virtual machine. So following a tutorial, so it could be so coding or simulation. Okay. If you face challenges, so midterm or final report submission, apply for a makeup midterm or makeup final. Okay, that's an easy thing. Don't vanish. That's a loss. If you're sure that you'll fail, apply for makeup. Because you get a second shot. Makeup's are scheduled a bit later, you get more time, naturally. Be it make a midterm or make a final. Apply for it, utilize that. All right, any other questions we have? So if you have questions, it's best to ask all the questions in the Google Classroom. And I'll try to answer questions in chat, that is okay as well. But better to ask in the Google Classroom as well. So any questions?
I have a question regarding the
but if time is required, we might get 3 before.
Hello. Am I audible?
Anything else?
Hello, sir.
Share this link
Am I audible?
What link?
of the talk.
Yes, I'm in the classroom. So everything that you see today will be shared If you don't get it, remind me tomorrow morning. Okay.
Sir.
All right. Next is okay, extra credit is you learn something extra related to the course. Any course, any tutorial, any book, any research paper, any activities that has some relation to the course to get some extra credit. And we'll try awarding at least 0.01. Does it answer the question, Atikur sir? And Shakib sir, did you have a question? Would you like to write it down in the chat?
Sir, yes, sir.
Sir.
Sure, go ahead.
Yeah, sir. Will be the projects in group or individual projects?
So midterm, only the midterm is in person for 7 to 6, everything else is online. Okay? Individual. Everything is individual. We might think about some group activity, didn't plan yet, but assume everything is individual. There will be individual tasks, that is guaranteed. If there is something that I find, okay, some group would be helpful, then we'll think about that. But for now, everything is individual. Any other questions?
Sir, could you kindly go to the marks list?
Okay.
Sir, so basically after midterm, proposal, project implementation, presentation, and faculty, they are all.
This is not time-wise sequence. The proposal for based on time will go before midterm. Yes.
So I was asking basically, are they combined total part of our final project or not? CSA 424 we had final project, so we had separate report and another presentation.
So everything is separate here.
Everything is separate here.
Separate tasks with separate deadlines and stuff.
Is it?
You build on that. You build on that. Maybe one task will lead to another. You build on that, but it's best to think things separately. Maybe you're building on proposal and then you're going to next step coding like that.
It will be the same workflow as we did in
Somewhat. Okay, any other questions? Ben? Yeah, sure. Interesting. Excellent. Okay, if any 7 or 6 people want to attend things offline in person, you're welcome, subject to available of the seats. We have very limited chairs available, so few chairs maybe. If you can find a seat, or if you're okay standing, you can attend the quiz in person. Okay? So, any online people in person is possible if chairs are available. But limited, it's not open, the offer is not available, but you are welcome to be here. Oh. Again, this is for the quiz timings will be announced in the classroom. In Google Classroom. Okay, any other questions? Ready? Okay, what type of work we have to do for the project? We have what? The concepts common for everyone. So you might choose a research heavy work, or you might choose a programming heavy work. So you could be a practitioner, you may be aiming to become a practitioner or aiming to become a researcher. So either research or practical programming. You can choose GPU, you can choose tensor processing unit, anywhere, or even you could something like what's available resources you have. So hardware and software stack you choose, and languages you also choose. So based on your comfort zone. But you have to show, even if it's research, show a proof of concept that something works, or some simulation tool as well that you work. What are you trying to achieve? We achieve a better performance, a faster work, or even manageable work. For some things, we are not even aiming for a faster thing, because it's not possible to get it done normally. So there is no comparison. Some work is simply not feasible with existing resources. Not feasible. So we cannot use the term faster because it's not getting done. At least getting things done, that is an achievement, which is impossible otherwise. If a model requires, say, 20 terabyte RAM, hard to do it on our machine, right? Even if it requires, say, 200 GB RAM, one machine is difficult, unless you're looking for a server. If you're trying to combine memory, processing power, or disk from multiple machines, that's some achievement. What is planned for it? Does that answer the question, sir? So any way of parallelism, anyhow, any concept, to any extent, you get things done. Let's go forward and understand. Okay, so we're thankful to Professor Justin for sharing these resources. Okay, so we're going to look at different concepts related to parallel computing, look at different types of memory architecture, different models of parallel programming. We'll have some discussion how to design parallel programs, some examples. Let's see. So usually, even for most courses, what the code that we have written is for serial computation. Your work happens step by step. Anybody ever wrote a program where the work works in parallel? Anybody having that experience in any domain?
So is more centralized learning related to parallel computing?
Somewhat, I think.
Like, sir, for our thesis, we are doing work on federated learning. So this works on the training on local machines. The
But
training is done on
well,
local
you are doing some work in parallel, yes.
So this is part of it.
Right. Okay. Did any of you use a software which has parallel computing? Any of you ever used such a software or a system? Nobody?
We have
Which one?
any kind of modern program that requires like
Can you give example of what software you have used that has some sort of parallel computation?
a game that I'm playing, for example.
LLM uses parallel
Which one?
LLM.
LLMs use parallel programming. Anything else?
Sir, model training.
Very hard to think. So we have heard about games and LLMs. Anything else?
The operating system.
Operating system. I've been waiting to hear that. All of you use operating system, and these are parallel by nature because you have multi-core. Your system has multiple cores, so you are using some sort of parallel computation. Maybe the cores that we write are not parallel. Our operating system is parallel, otherwise you would not be able to run more than one program at the same time. If you move your mouse, everything else will stop because mouse program is run. But it doesn't happen. Things keep working, right? So your OS is the biggest example of the parallel system that you're working with. We used systems that had less parallelism. Okay, so parallel is better because you're getting things done, and many different kinds of parallelism. So think of it as a very loose. Why? We have to save time. Save time and money. So we have to get things done faster, cheaper, and overcome memory constraint because it's not fitting in one system's memory. So you want to distribute the work, and it's the future of computing. In fact, it's the present and it's still the future because people will keep getting more parallel, naturally. So there is a term called ubiquitous computing, and for those IoT, we are gradually moving towards your smartwatch, your smart glass, your phone, your PC, your Wi-Fi router, your fridge, your car, all working together and sharing some sort of sensor data and some computation. So everything is getting interconnected, and you'll be doing some ubiquitous computing. You are already using your smartwatch for your SMS, and you have sometimes call access as well. Okay, so there is something called Flynn's taxonomy. What taxonomy? Flynn's taxonomy. Some people are noting it for the quiz already. Okay, Flynn's taxonomy. So what we have, it is based on instruction and data, command and data, instruction and data. So it's like 0, 1, 0, 0, 0, 1, 1, 0, 1, 1, right? It's a single instruction, single data. So you're giving command to one command for processing one data. And single instruction, multiple data. So sometimes you'll see this abbreviation, SIMD. SIMD is seen more commonly. Single instruction, single data. Single instruction, multiple data. So all this, multiple instruction, multiple data. Now, each of them have different kinds of application and different usage. Not all of them are used very widely. Some more, some less. So it's a way of organizing the work in this area. So what you're trying to code, or your assignments, how you're trying to code, you'll try to align with this. Or when you're looking for resources, help file tutorial, you'll probably look something for some manual aligned with this. Okay. Next example of each of these. So single instruction, single data. This is the most common type we have done in our programming courses, software engineering courses, and all other stuff. So you start getting some data, load A and load B. So some data, you are doing some computation, maybe storing the result, further computation, storing back the results. Serially, sequentially, one after another. Regular programming. It could be loop conditions, fine, that's okay. But instruction stream and data stream. What's a stream? What's a stream? Flow of something. Jharna, flow of something. Stream. Did anybody use the C++ programming language? They have something called IO stream, input and output stream. So input and output is also a stream. It's not just one input and output. It's a sequence of input and sequences of output, because they keep coming and going. So you have a data stream, sequence of data, and instruction stream, sequence of instruction, or instruction coming after another. So in one clock cycle, you're working with one instruction and one data. You think of it like a unit time. One clock, this is a CPU clock or processor clock, CPU, GPU, any processor. This is not a wall clock. The clock on your wristwatch clock or wall clock, right? These are different clocks that you know that. Your computer has a clock. How many clocks do you have in your computer?
So instructions per
How many clock? No, not clock speed. How many actual clock counter do you have in a computer? What is that clock called? Probably RTC, real-time clock. And you have a clock generator. Based on that, you might have one or more virtual clocks as well, because your memory is running in each device is running at different speed, right? Clock speed. So accommodate for that. So you have one or more clocks in your computer. Okay, that was what? Single instruction, single data. Now we are moving to the second part. Moving away from our comfort zone. Okay, so we may have done a bit of these. So, instructions. We're loading, so different processes, different processing unit. It could be different thread, it could be different process, it could be different machine. So, or it could be different cores of the same machine. So we are having different instruction or same instruction on different data doing competition. So what we in parallel. So it could be sorting different part of the array at the same time. Sorting different part of the array at the same time. The instruction is common. Sort or swap or compare. Any question on this part? Multiple instruction, single data. Is this a real thing? So one is used in cybersecurity. You're trying to apply different kinds of code cracking, decoding on a single encrypted hash. Even though it says very practical usage for this type of classification, but I think we are evolving here. In your all those AI models, you're sometimes also doing things like that. You're applying many different models on same data set, trying to make sense of which model works better. So increasingly we'll go into that area. So there is, and increasingly we're combining multiple tasks in one model. Multiple tasks in one model. So by one training you get multiple things done. So that's also increasing. Single model. Now, multiple instruction, multiple data. So there's another kind of parallelism. Everybody's instruction is different. One is loading some data, another is calling some function, another is doing another loop. And this is the most common parallel task. So it's like a distributing work to your group members. Each of them are working on a different part. You write the report, I'm working on the presentation, I'm doing the coding. You collect data. Okay? Does it make sense? So that's the most common part that we are familiar with. So now can anyone repeat all those four stuff?
single instructions, single data.
Single instruction, single data. Then
Single instruction, multiple data.
single instruction, multiple data.
Single data.
Multiple instruction, single data.
Multiple instruction, multiple data.
Multiple instruction, multiple data. What is this thing called?
Flynn's
Flynn's taxonomy. Okay. Other terminologies, regular task. We are doing logically discrete or separate tasks. Logically discrete. I'm sorry that we could not turn off that light. These three lights are together.
Oh,
If you turn that off, it becomes a movie theater, so cannot do that. If you can find the switch of that light. Okay, so logically separate task. Second is parallel task that can be executed parallelly. There is a safety clause here. What's the last word? Safely. Parallelism could be unsafe. How is it possible?
multiple instructions can have multiple data as output. data
What hazards could be there if multiple people doing work together? What hazard could be there?
overriding.
Overwriting, corrupting the data. If you are not sharing it well, everybody working on different parts of the report, they'll be overwriting different, maybe, and it's like stepping on each other's shoes, so maybe you're overriding each other's work. So it's not just parallelizing the task, it is also doing it safely without corrupting data. That is very important because every parallelism is not safe. Okay. Communication, is that required thing? Why do we need communication?
Processors doing different or the same tasks, so they need to communicate with each other.
Some coordination is required. So it's multiple processing unit. It could be full processor, it could be process, it could be thread on same or different machine. So you need some kind of communication. In operating system course, we have heard about something called IPC. What was that? Inter-process communication. How do you do inter-process communication? What are the ways? Multiple ways.
Shared memory,
Shared memory. Anything else?
message passing,
Message passing. Anything else? How do you pass messages?
using functions.
Okay. Anything else?
In pipeline.
Pipes. I'm not sure if it's called pipeline, at least pipe. Okay. Maybe pipeline thing. Anything other than pipes? So pipe is it's like a real pipe. So in one end you throw something, other process receives. Anything other than pipe for inter-process communication?
So using flags.
Okay, some sort of communication flag. Anything other than that? Have you used, anybody used you're all Python batch, right? Anybody? C++, Python, Java, okay. So have you used any debugger tool or communication? So
Exceptions.
for debugging, step-by-step debugging, have you used any tool?
Like Python.
Okay. So some software will have different portions communicating with different techniques of IPC. One of them uses also network stack. You communicate over the network stack. What IP do you use? 127, the local host IP, right? So you could be communicating it in pipe or also network stack. We used to use a software called Dr. Java. It had something called interaction pane and the upper pane. So the two parts of the same software used to use two different Java runtime environments, JRE, and they were communicating over IP. So every time you start it, you have to add an exception in firewall because firewall is blocking it. Communication between two parts of the same software. So communication, and then naturally comes synchronization, coordinating. So in early days, what Google tried to do is try to make their system parallel, redundant, with cheap hardware, which is refurbished computer, which means second-hand computers. These are second-hand computer, maybe third-hand, that means they're failing anytime. Software or hardware failing anytime. RAM failing every day. Processor, power supply, any component failing every day. It's an old machine. Most random parts failing at random time. So they made their systems resilient to that. Those are the early days of MapReduce, big table. So all the early old days, they had to face all this. That's how all the collaborative computing started coming in Google scale. Because things are failing, you cannot depend on. That means you have to be redundant. For your group work, you probably assign same task to multiple people. If one fails, you still have one backup. Some of you are using probably mobile data as a backup to your internet connection, right? So synchronize the work. Sometimes you assign duplicate work. Sometimes you do timeout. Okay, I'm going to wait 5 seconds because either the code that you assign the task is not done with it. Maybe it needs more time, or it froze, or it got disconnected. How long are you going to wait for the results? If your groupmate is not replying your calls, texts, or giving the task, how long do you wait? 1 month? Probably not, right? So we need some synchronous communication, and we also need some redundancy or your timeout, because we might need to assign multiple tasks because of the failures. So that's how the fault tolerance come in. And the second thing is not just, okay, even if they gave it, even if the processor got it done, but how do you just connect? You have to verify. In order to verify, you have to give the same task to multiple processing units, right? And then cross-check it if something is of importance. Granularity. So some tasks will require more communication and less calculation, and vice versa. Some tasks will require more calculation and less communication, depending on the nature of the job. There could be a middle ground as well. So the ratio would vary. So more communication, less computation. Overheads. If you're trying to coordinate with multiple resources, you'll have natural overhead. What is communication overhead? How are you communicating? Maybe over the network, maybe over the RAM. There would be some latency, even if it's the same machine, there would be some delays, natural delays. It's not full real time. It will have some natural delays. If you're doing it over the network, and network is inherently unreliable, it will depend on the protocol. Processor might be busy. Network might be full. Okay. Is your internet connection good? If you're satisfied, alhamdulillah, fine. But don't blame me for this. I'm going to give you another optional task. So don't become sad or upset. Search for waveform buffer bloat, waveform buffer bloat, and test it. If the results are not, there is a side effect of doing this, okay? The moment you run this test at your home, you'll become unhappy. Even if your internet connection is good, because by comparing, we become unhappier. Your connection is good, I'm sure, alhamdulillah, but once you test it, you become less satisfied. The moment, I'm sure you're using a good phone, the moment next version of the phone comes on the market, suddenly your phone will start feeling slow. For no reason. It's psychological. Because a newer version is out, a faster version is out, you'll feel slow. Before that, everything was completely fine. So it's testing. Let's see what grade we get. I'm sorry. So it's better not to try this at home, right? If you're happy, remain happy. No need to become sad. Some of you probably, it's not very reliable on phone, but you could try on mobile data. Okay, so waveform buffer plot. Okay, it's optional, not compulsory, optional. In the class task, we missed one. You have another computer at home. Can anyone guess what it is? Right, excellent. Wi-Fi router, okay? So second task is test some communication overhead. It's not all, some communication overhead. Okay. The overhead would be coming naturally. The communication could get lost. Either sender or receiver could be busy. It could be inherent by system, compiler, libraries, tools. Okay, how do we know where is the time going? Have you ever compiled a program? Did you run? Does it run in a lightning fast speed? It takes some time, right? Even a few milliseconds, right? Do you know how to test how long a loop runs for? Have you ever timed your program? Profiled your program that my program requires this much space, RAM, and time. Did you ever test?
We'll have assessment how long the loop lasts.
That's a good thing. So can we do it ourselves in local Python IDE? What do you use? VS Code or some studio, Android Studio or something, any local IDE, PyCharm, Spider, Anaconda. So do you know how to do it in locally in any programming language, C, C++, Python, Java, Fortran, or Kotlin?
I understood.
How do you measure how much time was taken by your program? Time, memory, and other parameters.
So if you execute code from in the output, it usually says
With seconds.
the execution.
Execution time. Seconds to start the program or end the program.
Finish the program.
Finish the program. Okay. So I want to run everything. A maximum RAM it could take. Okay. This concept is called code profiling. What is this called? Code profiling. So you're profiling a program. Profile. Creating a profile. Profiling, measuring. So sometimes your ID has this feature, sometimes you need external tools for this. Try this. Any programming language, find out what code profiling tools are there. You want to know. Because in our time, whenever we used to buy something, any game, any operating system, it used to tell how much processing power is needed, how much RAM is needed. Name the software. Name a software. We're going to check how much resource it takes.
DLC.
PLC. Okay. AI answer is okay, but it would have been better if he would find a concrete link. Okay, let's take AI answer for now. Minimum requirement is what? 500 megahertz processor. That's half gigahertz processor. 120 meg RAM, 30 meg hard disk. That disk will vary from system to system. And the RAM requirement varies based on 64-bit or 32-bit. So 64-bit requires probably double the RAM. Okay, another requirement, graphics and other requirements are there. So all software will have hardware and software requirements that has to be met. How do you know? How do they know that their software requires this much RAM? Somebody had to measure during some step. So how do you do the same for your system? Using code profiling tools. For what language you choose, right? You're doing Java, Python, you choose your tools. So find out the code profiling tools for language. Run any program. Run a sorting program in any language of your choice and measure how long it took. Even if you don't find such a tool, there are ways to measure time. So we print time, okay, I'm starting the program, on top of that we print the system time or clock ticks. And then at the end of the program, just before exit, you print another thing, and that will give a difference of clock ticks or system time. That way you can also measure. Okay? So try code profiling tools for your language. Okay, so try this code profiling tools. Okay, so we'll have overlap. So some things take time to compile, time to load. Loading a library. Why does your game take so long to load? Loading all the resources, browser, or even the operating system takes time to load. Next, architecture, parallel memory architecture. Looks very interesting, ideal world, right? All CPU sharing a memory. Our dream. So all process address a global memory space. Again, this could be hardware or software, but typically we are mostly referring to hardware. So data sharing is fast. It's common memory, everybody's sharing. But we are lacking scalability. Why? Why does this lack scalability?
The limitation to how many CPUs we can connect.
Right, it's a physical limitation. How do you connect? How much? So you'll have some limitation. And how much memory can be there, and some sort of coordination addressing. So there will be over somewhere we will say it's difficult. So it's not very scalable. So we need to look at alternative solution. Because what?
The bandwidth is fixed.
Bandwidth is another issue. So all the pipelines, so the architecture will also be challenged because you're sharing stuff. Second, distributed memory. Okay. So everyone has their own separate memory and own their computing unit. So they do their calculation on their own and they share the relevant coordinate. That's more scalable because once you're on the network, you can attach more on the network. Fine. So you can collaborate with 10 computers or 10 billion computers. So we are away from hardware limitation, but where did we increase in complexity? The network and programmers overhead. So now your program has to be resilient to individual memory, CPU failure, and network failure, and delays. Not just failure, delays. You're not unreachable. Do you wait? How long do you wait? Data could be corrupted or lost. So programming has to be a bit smarter to be able to synchronize all that. Your mobile apps are a bit resilient to your network failure. Your phone network is not constant, right? You're not connected to wired networks. You have losses. You go offline, online. You go to lift, your phone doesn't crash, even if it got lost the network connection or browser error doesn't come. It waits. So programming was smarter to wait. If some things fail, it will wait and preserve that state. Have you ever faced connect timeout? Timeout in connect. If you relog in, you get back the state where you left off. Do you get back the same screen if timeout happens in connect? Maybe sometimes. Not sure. Okay. So parallel programming has some abstraction. So above the hardware, so it has to work on hardware. Okay. One side note: operating system, is that a software or hardware?
Software.
Software? Anybody else? Hardware? Both? Software? Okay. So the operating system that you use is a software, but people have implemented operating system as a hardware as well. And it works much faster. Why don't we use it? Hardware implementation of operating system. Why don't we use it?
Much more costly, probably.
Costlier.
Different hardware.
So we cannot write.
Harder to upgrade. It's not easy to upgrade. You have to upgrade. Upgrading hardware is costlier and less available. Let's go. Sometimes impossible. I went to the computer shop and told me upgrade my GPU. You cannot upgrade the GPU. This GPU is built in and the laptop cannot upgrade GPU most of the times. And some of you probably using all-in one computer, one monitor has everything. Those have less upgradability. So upgradability is an issue. But it's going to be blazing fast because everything together. So hardware implementation operating system is really fast. Some things you do, if you're sure about that, why are did big corporations design their own CPU, GPU? So what? Who did first? We don't know, but Google had their own tensor processing unit. Apple did their own hardware design. So big corporations have their own custom design of hardware for common workloads that they're facing. Again, there are general purpose CPU, GPU, there are general specific purpose processing unit as well. You're familiar with graphics card, right? Did you know we saw something called physics card? Have you heard of that? We have separate physics card. Now it's probably built into the GPU, but at our time we heard about that. Separate physics card. Thank you for sharing. Okay, so let's look at example of different models: shared memory, threading, message passing, and data parallel. So let's start. Okay, so if it's shared memory model, user sees single shared memory. Despite the hardware implementations, it could be different. Locking and semaphore, what are these things? Anybody remember your operating system courses?
Yes.
What is locking and semaphore? Synchronization, yes, helpful for synchronization. Can you give example of any semaphores or how it's used?
Basically used when we are accessing any kind of global variable or data so that we can ensure data integrity.
Excellent. It could be okay, access control among multiple users, or even it could be for same user as well, but different process and threads. You have seen something similar in database as well. Databases also have locks, right? There are locks on record. One record cannot be updated by multiple users at the same time. Does it make sense? Do you remember that database locking? Two-phase commit protocol, something like that. There is three-phase as well, or multi-phase. Why do you lock? What will happen if you don't lock?
Corruption.
How do data get corrupted? Sharing is caring, right? Sharing is good, right? How do data get corrupted?
It can be overwritten.
If we update, we have to override data anyway, right? So is that bad thing?
Unauthorized.
Could be authorized too. It's not always happening as a genuine user. So you could be doing true transaction with the same account on the separate machine and have spent more than what your existing balance is. Because so you have maybe 5,000 taka balance. You're withdrawing 4,000 from two different machines, and both of them work because it's not locked. Locking will ensure that one executes before another, so you don't have sufficient balance for the second transaction. But unlocked will become corrupt data in a sense that you're withdrawing much more than what you have. Or even your sound card, graphics card, microphone, some software will have exclusive lock to it hardware, so others cannot use it at the same time directly. So software locks is also possible. So locking is for access so that it doesn't get corrupted. So semaphore, can anyone give examples of semaphore? What types are there? Excellent, binary semaphore and counting semaphore. What that might be? How does binary one look and how does counting?
Binary to 0, 1.
0, 1 or true, false, something like that.
Starts with the 6.
So counting up to a range of values. Excellent. So you remember what am I here for? Okay. Okay, so this shared access is making programming simpler because we are having not worrying about the communication part is being dealt with. Excellent. I will sometimes might forget about your breaks. You have to ask for it, right?
It's okay with them.
Okay, how long of your break would like? Do you need 10, 15, 20? What would most people like? Okay, somebody chose the middle ground, so 15 minutes, okay? Okay, see you in 15. But do not stay beside in front of your machine or phone, just more sexy. Of course, it will have some overhead. So here in threads model, you are determining all parallelism. So if you want OS to be able to deal with that, you have to code accordingly so that OS can schedule different, assign different part of your program to different CPU core. Okay, so on that note, let's try something. If you're, thank you, Marzuka sir, for sharing. If you are on a PC, open your task manager. Open your task manager if you're on a PC. Do you see anything? So we are here in the task manager, okay? In the task manager, we are there. And we are going to a task, maybe Firefox, and going to a single process. We are having, again, one program having 38 different processes. Under each process, there will be multiple threads. So clicking on that and then choosing something. Is it the process list? Okay. We're in the process list and setting affinity. So here we get an option to assign this process with different processors, right? Because Firefox was developed being parallelism aware, so it can utilize all the logical processes that you have. But not all programs will have this option because their program is not parallelism aware. Okay, so here is all processor done, or you could restrict, okay, this CPU, you could try that. Now in our processor architecture, there are some differences. Let's go to performance, and here choosing the CPU part, going to the CPU. So this computer, what we have? We have 14 physical cores and total logical processors 18. That's why you are saying that. And this is the base speed. So if it gets overclocked, maybe it will reach 2 point something, maybe 3 gigahertz, something like that. But that's overclock, temporary overclock. And there are different cores. Some of these are performance cores, some of these are efficiency cores, depending on processor architecture, whether or not virtualization is enabled, different levels. So you get this. This machine is, okay, that 1.2 is getting overclocked temporarily to this 3 point something gigahertz. So 210 processors running, under that 3000 threads are running. And this is the overutilization. Okay, so let's break it down. Let's see the utilization per core. What do you see? Can anyone comment on what you see? Okay, let's have this. What do you see? Is it visible? Do you see what's there? Do you see the graphs from the last bench? We're talking about the blue curves. Okay. So we are seeing 18 plots here, right? So 15, 16, 17, 18, total 18 plots. What are you going to comment?
The CPU is not fully utilized.
Good, nice and very good realization. CPU is not fully utilized because we are not giving it enough load. Okay, that's one. But apart from that, because we are not running a lot of programs, apart from that, is there any other differences?
The speed is much higher than the base speed.
That's getting temporarily overclocking. Do you see anything else?
So it's virtualization enabled.
Yes.
Why we can use parallelism. Or
Okay, virtualization enable more parallelism is possible. Virtual box can be run, for virtual hosted system can be done. But do you see any other pattern?
the number of processes are constant.
Because we're not running new programs. Okay, so some of us were unhappy about the CPU load, so I have started something. Hopefully that will increase some load. Okay. Maybe from this position, or maybe we don't have enough load, we can temporarily switch. Do you see things clearly?
Yes.
All those ECT ports. Do you see any pattern? Do they look all the same?
No, sir. No. The first two cores are being utilized more than the next
It looks like they're out of phase. Out of phase, and they have different amount of loads, right? Different amount of loads. Some even have different kinds of spikes. Some are more or less constant use. So that's the challenge. That's the challenge in any system. We have been talking about parallelism for decades. Still, this is what? Probably the latest processor, right? What is the Core Ultra 5 125H? Let's see. Before changing, we're looking at the graphics and different aspects of graphics, shared memory. Okay. So tinker with these at home. We're going to, what was the processor? Core 5 Ultra 125H. Let's see. Oh, does anyone know when did this come? So call ultra. I'm not sure if it's this one, but that's so. Okay, so this is within last 2 years and being called Meteor Lake, something like that. So this is pretty recent. And what operating system is this? This is Windows 11 Pro, professional, right? Professional, that means this is heavy workload ready. It's not home edition, right? So this is workload heavy. So this, with all those logical processes, this is supposed to be smarter, balancing the workload, but still you see all the graphs are different. That means all the cores were utilized differently. That means still, with all that smartness and all those variables, how many processes did we have? Over 200. Over 200 processes and over 3,000 threads. We're still unable to balance the workload across processes. Of course, there are also other reasons. Maybe this is, some of it is could be intentional because reducing core count for performance reasons in a different way, that is power performance. Maybe you're trying to reduce heat and electricity usage. If you run all the cores, it's gonna take up more electricity, losing battery power or electricity bill, costing electricity bill or heat dissipation cooling cost. So maybe it's intentional part of it, but still, if you lose all those optimizations, still it's hard to utilize all the cores equally because it's hard to distribute because all programs are not equally made. Does it make sense? Even the older Microsoft Office was not parallelism aware. It was taking a lot more time. Did you notice that multiprocessing mode in Excel? Did anyone notice that? Trying to do something in Excel and see all processes working? No? You don't use Excel? I'm trying to show you the option in Excel. I believe you have it too. In many of the software, you might have the option to select that. What we did is went to the file menu, options, then went to advanced, and at the end, enable multi-threaded processing. Enable multi-threaded processing, okay? So let's put it to use. What I would like you to do is monitor this status bar here. At the lower bar, monitor that area. If it does not freeze, we should see. So let's give it a small workload. Excel is not smart, cannot deal much. Let's try this. Need a bit more load. So you briefly saw the percentages at the bottom? No? So gradually it's doing in 18 threads. It showed all 18 threads were being used. If you could do this large enough to last in, I think, several. I'm trying to show the whole screen now, so you'd see better. Right now it's finished, I guess. Yes. So it is so busy as working. It's gonna show here processing in 18 threads. But while not waiting for that, let's see. The cores are being used, right? Machine is increasing in utilization. But what happened? Last two cores being not that much, and all other cores are not being equally used, right? Some spiking, some less spiking. So we have given it more workload with 18 logical processors, and still we're not able to distribute the work much. Are you happy with this distribution? And again, is it done? Still not done, right? We're still waiting for the machine, but not being able to use the fullest power. And you might be blaming, okay, you're on battery power, not performance mode. It's not. It's on, not on energy saver mode, it's disabled, right? We're not on battery saving mode. Still, we're not being able to. Still see, it's not still under process, still frozen. So they have done well, they need to improve further. Does it make sense? Of course, maybe you preserve some ability to interact, because if you use full power for Excel, your operating system is going to be less responsive. If you want the operating system to still talk to you, you have to leave some processing power for the operating system. Does it make sense? Okay, so there is some, right, do you see? Did you see? Calculating. Now the random part is calculating, pasted formulas. So see how slow that is. Over 18 threads, it's still calculating random values, right? Because it's having to calculate many thousands, still significantly slow. Can you believe a modern processor with all that? Let's see how we are doing now. All right, more spikes. if, who developed Excel? Some soft, right? Some soft company. So now they have what? World-leading engineers globally. They have offices in many countries. Our program, so we need to be able to do much better than that. Any program you do, any language, try to incorporate some parallelism. What will happen if you do? It will become more scalable. You want to design your program, you want to be make it more scalable. You'd like to handle maybe millions or billions of customers. All those database operation. Whatever database you design, whatever front end, back end, full stack should be scalable. Does it make sense? Any program you made, any software you made, for how many customers? 500, 1 million? Test that, measure that. There are tools for that. And then, before that, you have to design it accordingly, so you know how to deal with that. Anybody tried a web-based project for anything? Okay. So you made a web application. How many users can it serve?
So I didn't test it, but
Assumption is fine.
about 100 users at a certain time.
Maybe. So there is a difference concurrent users and total users. So you're talking about concurrent users. At the same time, how many people can it serve? So without failing. So before connect, you remember what was there, right? Too many people log in and everything goes white. So, and even in connect, what do we have?
There is the throttling mechanism which throttles the request. There is too many requests to the
Not just that. Can everyone log in at the same time? No. Why?
that requests that are going to the machine are delayed.
Not just that. Can everyone log in? No, you're slotted. Why should that be?
Too many.
In ideal world, there should not be, right? Everybody has a right. Because for credit courses, for major courses, I understand. For electives and pods, so there is also certain logic for sequencing, but don't disturb. Okay? Nobody interrupt us. We are plus that at least in Japan, this is highly respected. At least you are here. Maybe you have your challenges. At least you are here. That is well respected. Okay, so let's not disturb. So we have to think this for database front end. Both has to work together. So scalability has to be both places, and doing parallel is important. All right. So things have settled down, and we have seen the limitations. Let's see how memory does, whether it frees up the memory. We have closed the application. Do you see Excel running? No, right? Memory shouldn't be free immediately.
It's closing the background processes.
Closing the processes. It needs time, right? Decreasing. How long do you need? You're a machine. You should work faster. It's still not fast enough. Was it this level before we ran? Was it 40%? Did anyone notice? Maybe that's the limit, okay? So there was a lag time, right? So clean up, memory thing, that's also an intensive operation, has overhead. That was the point. All right, let's get back. So we were here to process can have multiple execution paths, shared memory, and programmer is responsible for the all parallelism implementation. Excellent. Message passing that you were talking about. So the task, the coordination is done by passing messages. We have distributed memory, and we have cooperative operation, one sender, one receiver for each operation. And what is the standard for this? MPR, message passing interface. You'll find libraries for this, message passing interface, MPI. Next is, so parallelism is of many types. We'll talk more about this in next class. Data parallel. So one is process parallel and it is data parallel. You work same operation on set of data. So it's work with both memory architecture, shared or distributed memory architecture. Works well with both. And same operation on some set of data, separate piece of data set. Now, there could be automatic parallelism, or you could be dealing with that. How will automatic work? The automatic one is the compiler is analyzing the programs. Your code is being analyzed by compiler and checking if any part can be safely parallelized. And not just that, whether there will be meaningful performance improvement. And what is the most common place for improving? Loops. Why? Why is it identifying loops as target for automatic parallelism? Why are we targeting loops?
Constant run.
What's wrong with non-loop parts of a code? Excellent. It may take more time, but usually loops are running for many iterations. Any tiny improvement in a loop can have a significant impact on program runtime. Say your whole program takes 1 hour. The non-loop part takes half an hour, and the loop part takes half an hour. If you can reduce 1 second in the loop, which may be running a billion times, it's going to have significant impact. And loops are often nested. The more nested the line is, tiniest improvement in that line is going to have more impact on your program runtime. It's going to have significant saving. Does it make sense? So loops are, that's why often more target. Because anything you could do for that. Of course, you may be targeting other parts, but that's later. Because those parts may not be significantly visible. Everybody convinced that loops, why loops are the main target? If you have to do something again and again, you want to do that, improve that first. Versus one time. You don't care much. Second is, that was automatic. This one is manual. So think about a chemistry problem or physics, something like that. So you have calculated potential energy of different chemical formations, all the bonds and other stuff, chemical bonding. So you want to, for same set of molecules, you want to find out what is the minimum energy state. Why? Because it's the most stable state of that molecular structure. So how do you do that? You calculate all formations, calculate energy of each formation, and then find the minimum one. Because it's the stable one, it will lead to that. Now, for each potential organization or structure of the chemical molecule, you could calculate that separately and then take the minimum. So that's more parallelizable because it's maybe somewhat shared, somewhat independently calculable. But if you do you remember Fibonacci series or Fibonacci series? Every element is sum of what? Previous two. And there is also variation Fibonacci, previous 3 or n. So we have a dependence. So how much parallelization can do is limited there. Maybe you could do data fetching one, but not much. Not significant improvement is possible because there is a dependency. If you have dependency, that's a problem. Here you have data dependency. You have to look up data. So you cannot do much parallelization. So it will depend on the problem. So problem to problem parallelism changes, be it manual or automatic. Significant. Any questions so far? Now, say you want to split up the task. If it's a one-dimensional data, single array or like that. So if you could do block-wise that every process, you split up the task, okay, you made to 4 parts and 4 parties do that, or 4 types of tasks there. Or you could repeatedly recycle that if you're doing a small part and repeating again in a cyclic fashion. Both are, so block operation versus cyclic operation. Bit of that, repeatedly going through the cycles. For 2-dimensional data, you could be repeating that in multiple ways. So if it's 2D data, maybe you are computing something out of the table. Maybe you are computing maybe some of full 2D table. That's also possible. And giving it tasks. So everyone doing different part of the task. So you could organize it in many different ways. So in a block-based style, so you could do block allocation in these 3 styles or going cyclic in 3 styles. Okay, so cycle within a cycle. So distribute that. So task parallelism is achievable in certain ways. We have no idea how much challenges some people face in life. I had one student tutor, like a TA. So he always gets B plus or B plus type grades, and CGP is not increasing for years. I know his potential. I was asking, why don't you study better? And he says, sir, I don't have time for study. So every morning, so from Fajr he starts doing tuition, until night he does tuition. The only time he studies is in the classes, and maybe a few hours before the exam, and that gives him B plus. Doesn't have money. His father died during SSC, and he takes care of he and his mother takes care of the family. Now he is in very good shape, but he didn't even have a scope for any retake, anything or CGP improvement, because he doesn't have any time for school. He does tuition, classes and tuition. No time for that. So we have no idea. We are very privileged and lucky in that sense. So I know some students who can't even attend the classes well, and maybe miss a lot of classes. Last semester I saw a student like that because his office didn't permit attending classes, so he only attended the weekend classes, not weekdays classes. So, okay. Now, if we split up, not based on just the, so your task will have different types of computation. So in a complex enough task or big enough task, you'll have different types of computation. So if you align based on type of computation, maybe you're doing all the sum here, maybe doing all the multiplication here, maybe doing all the inference here. So if you base depending on tasks, now this could be another type of parallelism. In fact, this would benefit from different tasks, would benefit from all these specialized processing units, right? So if you're processing tensors and you put that in tensor processing unit, that's going to be fast because that's a specialized core for that.
Is task parallelism?
Task parallelism. So each task, so if we didn't even go for execution, you're just separating tasks based on nature. So of course, each will have different proportions. So this is a very good illustration. All tasks, what is our psychology? All tasks is same size. We're splitting them, it's not. Maybe, so task 1 is double as task 4 or task 2. This program will have different proportion of different type of task. So, array. Do we understand what's an array? What is an array?
Structure.
It's a structure. Anything else about the array?
Sequential data.
It stores the data sequentially, but we have random access. Array has random access, but so what it does is operating system guarantees all the data are adjacent in the memory. Does it make sense? What's the benefit of that?
Faster.
How?
Continuous memory.
So you could jump into any portion. That's first step, indexing, access. Anything else? Any other benefit of having adjacent memory? You could accelerate performance, you could prefetch data because you know you're going to read the next one. So without needing it, you can preload next page's data. So you could do more acceleration. Does it make sense? If you know you have to do next task, next pages, you could say maybe you're turning all the pages sequentially. You're reading one page, but on the hand, you're holding the next page that you need to do. But you're ready to run the pages. See, if memory is adjacent, if data is adjacent memory, you can do much more prefetch. So that's the memory prefetch. It's going to accelerate your data processing because you're loading it beforehand. So two-dimensional array can be created in both cache-friendly manner and non-cache-friendly manner. If you're doing dynamic allocation of every row, that's less cache-friendly because each array in the 2D array is coming in a different memory segment. Versus if you allocate the whole 2D in one go, is going to be cache-friendly. Does it make sense? What is a 2D array? What is a table? If it's allocating as a 2D array, every row of the table, so it's in memory, first row besides second row. Every row is adjacent on the memory. So if you cross the first row, right next to you is the second row. That's a cache-friendly allocation. Versus you could create the same 2D array, but it will be each row on a separate memory location. Both are possible. That is called array of arrays. So both are possible. One is cache-friendly, one is not cache-friendly. One is prefetch-friendly, one is not prefetch-friendly. Does it make sense? C-A-C-H-E. Cache. So cache-friendly or not so friendly because If it's a memory location, you lose the prefetch. After, you get prefetch only within arrow. If you're jumping to the next, it's far away in the memory. So it's not sequential. You have to jump and wait for selecting. Okay, so coming back, in a serial simulation, you have to do something on a 2D array or a table. You go through single processor iterates. But if you do on the parallel one, so each processor works on different part, maybe one row or set of rows for each processor, depending on how many processors you have or processing unit each have. So they independently compute that, which is going to be much, much faster. Okay, transposition is somewhat like a swap. So transpose. So if you're trying to do bubble sort, do you remember bubble sort, boot sort? Okay, we're going to discuss more about bubble sort next day, but just if you don't even if you remember, you are doing looping through the array and swapping to adjacent elements. Okay, watch a YouTube video on that. Bubble sort. It is the first sort you probably saw. So now, if you would like to do parallelism, you could maybe swap each adjacent, so odd and even adjacent elements you swap. Now, what is the complexity of bubble sort? Order n square. Because you have an n element of array and your loop runs n times. So one loop inside another loop. Nested loop, both loops, the naive version, the basic version, both loop runs to the length of the array, full array. That is n square, n times loop running another n square. But if you could parallelize it, it will become order n, almost linear. So let's see the steps of tracing. You have 7 elements, but these are getting sorted in only 7 pass, order n. What? In first phase, you're swapping elements. In each phase, you're swapping the adjacent. This is the worst case, that is in descending order, you want to sort in ascending order. Ascending means low to high. Descending is high to low. So every pass, you're swapping the adjacent. So all the swapping is happening in parallel. You don't have to wait for next start. So in 7 pass, you have all done. So half time, not even half time, square root time. It was n squared, and now if you square root it, just n, order n. Is this okay? It's a parallel implementation. So sorting is one of the techniques used for demonstration. Okay. So what other parallelizable problem is there? So do you remember astronomy, the space, the galaxies, all the stars? If you want to calculate, so there is a galaxy, you have lots of planets or some astronomical bodies, you want to calculate their interaction, maybe gravity among multiple planets or stars. So there are multiple algorithms for this, but you want to calculate that gravity among different planets or astronomical stuff. So that task, that calculation is parallelizable. Now, this has very high complexity because the complexity is n squared. And if you try to complete with n body, means n planets or n astronomical things or n asteroids. If you try to higher n, it becomes huge computation because you're calculating gravity between all planets. But this people have tried develop different algorithms on optimizations for calculating in a parallel manner, making it more efficient. Floyd-Warshall, have you heard of this name, Floyd, in algorithm course? Again, I think it got temporarily disconnected. Already done. The slide is already shared. So the syllabus is just this slide that we discussed. That is the quiz, and the post was done in classroom as well. Any questions? Okay, now I'll have to rush a bit. So ignore the other file, only this slide. Okay, ignore the other files. Already posted in classroom. Okay, I'm gonna do the online first. Okay, so everyone online, please type your, let's do it in parallel way. Okay, it's gonna take, don't have enough time. Please post your ID and name in chat quickly. Oh, no, don't, okay, let's do that. Like this. So online people, quickly post like this in chat, okay? If you are connected, do. If you're not connected, we'll think about something. Again, you have 1 minute or so because this can get disconnected anytime and then we lose names. Okay, in-person people. I'm doing it in-person people. Aryan, Taiba, Kibriya, Devashish,
Yes, sir.
Omio,
Present.
Mir,
Yes, sir.
Abid,
Yes, sir.
Majidul,
Yes, sir.
Ariana, Sultana, Sultan, Ahmed, Duet, Muntaha. Anyone left? Okay. Which one? Sakir Tausif. Okay. Everyone done? Anybody left? Fariha, sir, I need your ID. Don't waste time typing hyphen colon anything, just ID.
Sir, Rohana present.
Everybody done?
Sir, Rohana present.
Anybody left? And those who are done giving attendance,
Sir, channel to
please,
9.
so we can see people who are still there. Like one. Yeah, I got it. So those who are done at giving attendance, please leave so we know who is there or not. I'll update in the sheet, so please see if your name is missing there. What grade did you get? Ahana Bhuya, are you saying something? If you're saying something, type in the chat, please.
Sir, can we leave?